Einstein's theory of general relativity shook the foundations of physics in the early 20th century, but there was one problem: conservation laws. See, what happened was, Einstein's special relativity visualized space-time as flat, but general relativity got all curvy, so conservation laws stopped working in their usual form. Conservation laws are so central to physics that most physicists began to doubt the validity of Einstein's ingenious formulation. Then came the mathematician Noether, summoned by physicists Klein and Hilbert to help solve this issue. After a few years of epic math, Noether's theorem was born. Essentially the bridge between mathematics and physics, it took various symmetries and tied them to associated quantities that are conserved in physical systems. For instance, we have a circle. Any point on this circle can be matched to any other point on the circle by a rotation. Thus, it is rotationally symmetric. Now, if we put an object on the circle and set it into motion, there will be some quantity of the system that will be conserved. And Noether found that that quantity is angular momentum. Likewise, a system that is time-symmetric, like this video for instance, since you can't tell if I recorded this video backwards and you're watching it in reverse, or if I recorded normally and you're watching it in the forward direction. Yeah, this time symmetry, it leads to the conservation of energy. Noether was able to use symmetry as a mathematical underpinning for why conservation laws held in most scenarios that physicists were familiar with, and why they did not hold in general relativity. Einstein's general relativity described space-time as varying, thus throwing time symmetry out of the window. This is why energy conservation did not apply to all cases in general relativity, a conclusion that was shocking to physicists at first, but became clear at the behest of Noether. Since energy conservation is a pretty convenient tool while working problems involving physical systems, physicists defined a quantity known as the Landau-Lipschitz pseudotensor that could take the place of energy conservation, as it accounts for all the losses and gains of energy in the scheme of general relativity to things like dark energy and redshift. While this sure makes things more convenient, it is still controversial in its application, as it may not capture the whole truth of the situation. Anyways, never mind this controversy for now. Despite her many obstacles in her career in mathematics as a woman, Noether was able to contribute a theorem to theoretical physics that completely changed our perspective on the nature of the physical universe and helped us solve problems at a much more fundamental level.